Okay, good morning all. Today we will start with cloud service models. Okay, now cloud services can be like a distribution of service or a service for linking the resources, computing functions, data store, processing functions, then network connections, okay, servers connections, and any applications. Okay, now the computing, that is a cloud computing, generally we can give it in the form of an equation. Like cloud computing is a uh, software as a service plus platform as a service plus infrastructure as a service plus data as a service. So it can be any of these cloud computing. Okay, so this is the like on based on this actually we study how actually the computing is done. Now coming to, now if you see the pictorial representation, okay, you get this. Here you can see it is platform as a service, okay, software as a service. Now here these are the databases. Okay, so data as a service, infrastructure as a service, like on which platform you are working. So that also is shown here. Coming to the individual this thing, software as a service. Now it is a software distribution model in which a third party provider hosts the application and makes them available to the customers over the internet. This service is made available based on the demand. Here, the services deploy and host at the cloud and are made available through the internet on demand to the user. So, actually, if you see, the service is run at the cloud. Okay, only the result, okay, of it, a computed result of it will be getting at the remote user. The software control, maintenance, updation to new version or infrastructure, okay, is done at the cloud service provider, and cloud service provider is responsible for all those. Next, coming to platform as a service. Now, here platform is made available to the developer of an application on demand. Okay, so it is a service model where the applications and services develop and execute using the platform, which is made available through the internet on demand for the developer for the application. Here, through, like when you request for a platform, okay, you can request for a resource, okay, you can request for a maintenance, updation, and security as per the like you can request, and as per your request it will be provided to you by the cloud service provider. Okay, uh, next coming to infrastructure as a service. Here, the cloud computing that provides virtualized computing resources over the internet. So, here also the infrastructure is made available to the user, okay, or developer of any application on demand. Okay, so the developer, it is a virtualized. So what is it? The developer installs the OS image, okay, then stores the data and application and controls them at the infrastructure. So it is in this service model, applications develop or use the infrastructure which is made available through the internet on demand, on rent. Okay. Uh, Here, the security and the resource allocation is the complete responsibility of the service provider in the cloud. Next, coming to the data as a service. Okay. Now, uh, here data is made available to the user or developer of application on demand. Okay, it is a service model where the data which is stored, okay, in the warehouse or in the database is made available through the internet on demand on rent. The data center management, okay, has to have a control, then 24/7 power, okay, then a continuous network maintenance, then scale up, okay. So sometimes, okay, data replication also is also required. uh, so these all things are controlled by the service provider. Service provider, okay, is responsible for all these functions. Okay. Next, we will be studying about two type in your syllabus. Two types of platforms are there for the cloud-based service. In that, first one is Xively. Okay, it is pronounced as Xively. Uh, so it is a application or service. So here the cloud-based service, like you can use it for data collection, data points, messages, okay, calculation, that is computing, all those things, even for the controlling. Here the server can be deployed at the edges. That is, edges means the remote ends, okay, which communicates the feeds to the cloud service. A data point, okay, when it if it generates a new data each time, a new sensed value should be recorded. Now a feed is nothing but again data and a connected one. A feed means a set of data points or objects, okay, or data streams, okay, which generate and communicate after application of rules, filter, calculation, okay, enhancing, all those things. So after that, whatever you get and you send it, that is called as the feed. Now, this Xively is a public cloud for the IoT. It is a platform owned by Google. This is actually the advanced version of the uh, called real-time, okay, platform called Cosmo. Open source for Arduino, okay, which is an typing platform that provides connectivity to the web deployment. It is Xively is a commercial platform for the IoT or M2M. It is can be used as a data aggregator, okay, and data mining website often integrated into the web of things. This platform supports REST, WebSockets, or MQTT protocols. This, like you know it, because we know that we are connecting, we are planning, our aim is to connect it to the IoT. So when it is IoT, MQTT, all those things come into picture. Those are the costs used. Now, actually, it works for Android, Arduino, ARM, Embed, okay, Java, then Python languages. Now, developers can use this, use the workflow of prototyping, deployment, and management tools. It's provided by the SID. Now, some basic concepts or basic features of the Xively are: it enables services, business service platform, which connect the products, okay, including the collaboration of products, okay, then rescue operations on the internet, etc. Here also data collection real time for the internet is possible. Okay, data visualization Okay, for data of connected sensors to IoT devices possible here. Graphical plots can be done of the collected data. Okay, it generates alerts. Okay, access to historical data, that is previously stored data, can be accessed. It supports Java, Python, Ruby, and Android platform. It generates feeds which can be real world objects of own or others. It supports the ARM embed based, Arduino based, and other hardware platform based IoT devices, HTTP based APIs. See here, this actually, if you listen carefully, it also supports the IoT as well as it supports the HTTP based APIs. Okay, easy to implement on device hardware, acting as clients to Xively web services and connect to the web service and send data. Okay, it supports REST also. Now here, a user to create an account with Xively when deploying Xively APIs for the data collection and other functions. Now, an API key from my settings is have to be taken. Okay. Now, once you get that, okay, get the key, and when you install, this device gets an online presence. Okay. Now, an Arduino, for example, an Arduino climate logging client, okay, that can be accessed via a browser or a mobile using Xively. So in this way, actually a developer or a user can access the internet that you through this platform and can start working. He can get the access to any data. Now, Xively is based on the concept of users, okay, feeds, data streams, data points, and triggers. So one by one, we'll look into it. Okay, concepts of users. Yeah, these are the services which I have told. And this is also, as I said, okay, Xively is easy to implement on device hardware, acting as clients to Xively services. Okay, then APIs can be connected to the web service and send the data. APIs provides services for logging, sharing, and displaying sensor data. Okay, next, yeah, Xively methods, okay, for this thing. So as I said, first one we'll look into, okay, push or pull, that is automatic or manual feed methods. Now, Xively provides two modes of data capture. Okay, one is a pull method, automatic feed type, where data is collected from the HTTP server, and push method, where data is written to Xively using a HTTP client. So both the types. Okay, you can send the data or you can get the data using the push or pull command. Okay, next, data formats and structures. Okay, it's here, all are here one by one. You need to explain this. Okay, data formats and structures. So number of data formats and structures enable iteration or data collection and services with Xively. Now, a spreadsheet, tabular or okay, Excel, text. So all these can be maintained in this data formats and structure, how actually it is written, the data. Okay. Next is private and public data access. If the account supports up to 10 sensor feeds updated in near real time and data is stored for up to 3 months. Okay, see, this is now actually for the who and all can get the data, how it has to be accessed. Interactive graphs provided by the service can be embedded onto the mobile, giving the application access to data anywhere. The application can even use other users' data feeds as inputs. Next one is data streams, data points, and triggers. Okay, data streams, data points, and triggers. So Xively enables all these. Data stream means continuous sensed data flow over the internet. Data points means data values, whereas trigger means it's an alert. Okay, action on a state change. For example, ambient light sensing. Okay, so below the threshold can give the trigger as 0. If it is above the threshold level, then it can give it as 1. Okay, or minimum, maximum, some threshold values. So in this way, it can be taken. Okay, next one is creating and managing feeds. Okay, sensors or IoT device network, such as a group of streetlights, okay, can be fed, can feed data to Xively over the internet. That actually example I will do it in the next class. Okay, then I can explain you how actually it is done, creating and managing the feeds. Individual devices can send the data streams for the sensed parameter to Xively over internet. Okay. Next one is visualizing data. Now, the Xively is a platform which captures data over the internet in real time and provides graphing, alerts, okay, and historical data access. That means it will be stored. Xively enables visualizing data of feeds and data streams. Xively allows the manual as well as the automatic feeds. Okay, so this was about the Xively. Actually, we have one example how actually this platform, not Xively, okay, any platform, for example. Next, we will be studying about the Nimbits. Uh, Actually, it works. What are the data? Okay, now actually, what are the data points or objects? What are the alerts? Okay, what is trigger and feeds? Okay, apply how actually this works. So when we take any one example, okay, how actually it works, we will get to know that example. I will do it in the next class. Okay, thank you.